friends, I am Jagan Mohan. So we have been discussing about the different methods of power generation. So in that we have discussed about the thermal power and hydropower also. So today we will discuss about the topic ILKS of hydropower. So what are the different dams we can have to produce the hydropower? Okay. So first thing is that it's the what are the different categories of the hydropower. See, if we are constructing a dam based on different constraints, so of course the dam is a multi-purpose dam. We are having different constraints of producing the power, storing the water, supplying for the agricultural land, and providing the tourism and providing the aquaculture, all these things. So based on different criterias, we can divide or classify the dam. So first thing is that according to the capacity. So what is the capacity of the dam? So is it a large dam? Is it a medium dam? Is it a small dam? Is it a mini dam? Is it a micro dam? And is it a pico dam? So what is the capacity? So capacity means what is the capacity of its power generation? Large dam. So first thing is the large dam. So first the governments will give preference for constructing a large dam. So first preference will go to the construction of huge dams, super dams we can say. See, if you take the Nagarjuna Sagar Dam, if you take the Three Gorges Dam, so always governments will give importance to construct a huge dams, large dams. So if you observe the Three Gorges Dam, which is the largest dam now in the world, which is constructed by the Chinese government, they have got opposition from almost all the countries in the world to stop that construction because it may lead to earthquakes. So it seemed that some people claim that they have used the nuclear bombs for diverting the path of the river and to divert into the actual path. So actually they are having some problem of that river, the Huanghe, which is called the river of sorrow in the Chinese name, which is called the river of sorrow, because it will be always changing its path. That's a big drawback. So like that, similarly, they are having some problem. So they have used it. They have claimed it. They have they have blamed that they have used that nuclear weapons for that purpose, nuclear bombing, to divert the actual path of the river. So in order to make a proper construction, but they have not considered it, and they have completed it also, because so it is the country with highest population in the world, with largest population, with highest population density in the world. So there is a huge, and also it is the country which is emerging as a superpower, which is very rapidly developing country. So they are having a very high very huge demand. They are having very huge demand of power. So that is the case why they have not considered all these requests or blames. They have not cared about all these things. So if the country wants to become a superpower, it needs so much of electrical power. So for its economical growth, so industries has to run continuously. So much of production is needed, and they have to sell all these goods, and they have to earn the money, and they has to get money, and that money in turn has to be invested in the military. So then only they can become it. So if a country wants to become a superpower, so it should have both the military power and both the economical power. For that source is that a good technology and very good exports. So with good technology, they can give very good exports, and also progress in military innovations. And with good exports, they will get good economy all over the world, and they will invest on the military side and for development of the country. Unlike the Russia. So the Russia is the country which is advanced in military, which is powerful in defense, but has become economically weak. So for that, all these things you need. So if you want to industries, a good industries with a good support of reliability of power supply, there should not be any shortages. So there should be a continuous supply of the availability of the power. So here, so that's why the countries always will go for constructing a large, for developing a bulk, for generating a huge amounts of power. So if that is not possible, then they will go to the medium cases and small cases. Yes, there is demand for small cases. There is so much of potential. So instead of constructing small 10 dams, so constructing a big dam, large dam, one dam is equal to that small dam. So that's why they move to that preference. They will give preference for always constructing a large. So here, so we are categorizing this on this capacity into into 6. That is large, that is medium, small, mini, micro, and pico. So pico is very, very small. Pico is very, very small. And based on the head. So this is also the decision factor, the impact factor, which will impact on the amount of power which we can produce. So there, with high head, so we can take an example of projects in our states, that is Nagarjuna Sagar Dam and Srisalem Dam. So everybody knows the Nagarjuna Sagar Dam is a big dam when compared to the Srisalem Dam. But everybody will get confused here that common people will get confused. So since the Nagarjuna Sagar Dam is the large dam, it will produce more power. So which is wrong. So the Srisalem Dam is producing more power than the Nagarjuna Sagar Dam. Yes, of course, the storage capacity of the Nagarjuna Sagar Dam is very, very high when compared to the storage capacity of the Srisalem Dam. But what is making the difference is, yes, the size of the dam, the capacity of the dam also makes impacts along with the head. So the head is more for the Srisalem Dam than the Nagarjuna Sagar Dam. So which is the twist here, and the Srisalem Dam is able to produce high power than the Nagarjuna Sagar Dam. So that's the thing which is playing the twist. So along with what is the dam, whether the dam is large dam or medium dam, in that large dam, again, whether it is a high head or it is a medium head or it is a low head, it will make difference, a huge difference. So we can consider both the Nagarjuna Sagar Dam and Srisalem Dam, or both these dams, as the large dams. But Nagarjuna Sagar Dam is more large than the Srisalem Dam, but because of the high head than the Nagarjuna Sagar Dam, the Srisalem Dam is able to produce more power than the Nagarjuna Sagar Dam, even though it is a large dam even though it is less larger than the Nagarjuna Sagar Dam. So this example will make you clear how much important is the head. So based on this head, we are categorizing that as into 3 categories. So previously, based on the capacity, we have categorized into 6 sections, and here based on the head, we have categorized into 3 sections, that is high, medium and low. And also next thing which will make a difference is that, which can make a difference, that is the purpose. So both multi-purpose dams, government also always prefers for constructing a multi-purpose dams. See here, the hydropower plants, no private multinational companies or private companies will show interest in constructing a hydropower plant because of various reasons. And here, so almost all the dams, which especially the large dams which we have constructed, are multi-purpose dams. So if it is a case, we have constructed a dam only for generating the power, are only for supplying the water. So then they are called as the single purpose dams. Then they are called as the single purpose dams. Generally, this type of construction, these types of dams will be very rare. Normally, they will be a multi-purpose dams. So if the capacity is more, generally it will become automatically, it is a multi-purpose. So ours is a country which is still depending up to 70% of population on the agriculture for their livelihood. So in this type of country, we have to make preference for agriculture. We have to balance the preference between this agriculture and both the agriculture and the power generation along with the tourism. So it is best thing to go for multi-purpose dams. And according to the facility of the types. See here, according to the facility means. So for constructing a dam itself, we need a geographical facility. Otherwise, we cannot construct a dam. See, if you go to KG Basin, if you go to Godavari Delta, so there the people are getting more water for agriculture purpose, but why they are unable to construct a large dams or medium dams there? Means, so geographically the situations, so already they are able to use it for the agriculture purpose, but why can't they can construct the dams like a Nagarjuna Sagar Dam and a Srisalam Dam in those areas, and why can't they use? So that is not possible there, because an favorable geographical structure should be available for constructing a dam. Otherwise, without that favorable structure, we cannot construct a dam or huge or a medium or large dams. Maybe we can go for a small dams. So that is the thing here. So the geographical favorable conditions plays a major role again here for constructing a dam. So the runoff means they are not storing the water. So they are just running with the runoff river. And reservoirs. So reservoirs we can go. And in stream. So in the river they are just placing some turbines and there. And pumped storage. So this is rare case. Very, very rare case we can find. So these are based on the facility. And according to the ecological relation, single or cascaded. So single means, so normally majority of the dams you can find are single dams. Single release. So once if you release the water, so you cannot. So the similar structure, similar type of favorable conditions should be there below this dam, first dam also. Then that will become a cascaded type of construction of dams. So this type of sites are also very, very rare. And the last thing is to the end side. So that is whether the dam, so whether the power we have produced after constructing this dam is connected to the grid, whether it is connected to the grid or not. So if it is not connected to the grid, that will become a isolated power supply. This is same for any. So whether you are using a hydropower or whether you are using a thermal power, whether you are using a nuclear power, whether you are using a solar power, whether you are using a wind power. So if the power which is generated is ultimately connected to the grid, then it is called as grid connected power system. If it is not connected, so it will become a standalone system or isolated system. So basically we have got an idea. So on what factors we have, on what factors we can divide the dams. So first thing is the capacity, whether they are large, whether they are medium, whether they are small, whether they are micro, whether they are pico, whether they are mini, or based on the head, whether it is a high head dam, whether it is a medium head dam, whether it is a low head dam, and based on the purpose, whether it is a single purpose dam, whether it is a multi-purpose dam, and based on the facility, whether it is a runoff type, whether it is a in-stream type, whether it is a pump storage type, whether it is a reservoir type, and based on the purpose, based on the hydrological relation, whether it is a single purpose, whether it is a single time, or whether it is a cascaded, and whether it is connected or not connected, whether so it is isolated or standalone or connected to grid. So here hydroelectric power plant. So availability of water flow, availability of water head according to the load type. So this is, so we have observed this, and based on the load, so whether the power you have, whether the power you have developed, the power you have developed is meeting all the types of loads, then it is very good. So that is not practically possible. So all the dam cannot meet all the loads because of some constraint. So here, if it is meeting a base load, so it is a base load dam. If it is meeting a peak load, so especially some cascaded dams, and peak load, and whether it is a meeting a peak load, fast load. So we are using the pump storage dams for meeting this type of loads. So based on the load which they are going to meet also, based on the load also, we can categorize these dams, hydropower dams. So first we have discussed that based on the capacity. So what is that capacity? We have told it is a large dam, it is a medium dam, it is a small dam, it is a mini dam, it is a micro dam, it is a pico dam. So if it is able to produce more than 100 megawatt, so not only its capacity, based on the capacity, so 100 megawatts, more than 100 megawatts, we can say it is a large dam. Based on the medium, so from 25 to 100 it is a medium, and from 1 to 25 it is small, and from 100 kilowatts to 1 megawatt it is mini, and 5 to 100 kilowatts it is micro, and less than 5 kilowatts it is. So if the capacity is the storage capacity is more, normally by default you will get good head, and we will with that good head you will get the good output. So and also next coming to the based on the heads. So the low head dam, why we are calling it as a low head? So based on the height of the water, which from the height, based on the height from the water, it is falling. So if it is 30 meters, okay, so generally we have this much even in the tidal power also. So tidal power also will have that much of 30 meters of height. So that is a low head dam. So if it is medium, so it will be, the height will be from 30 meters to 300 meters. 30 meters to 300 meters. So then we are going to call it as the medium head. And if it is the head from 200 meters to 250 meters or above 300 meters, so more than 200 meters or 300 meters, we are calling it as a high head dam. High head dam. So similarly, the in stream. So here in stream type of power. If you observe, here we have not constructed any dam here. We have not constructed any dam. And simply we have placed some arrangement of turbine arrangement. So with that current of water flowing in the river, the kinetic energy, with that kinetic energy, and we are just using. So we are not increasing the level of the river here. So just we are inside the water, we have placed that equipment, so which will rotate with the kinetic energy of the normal flow of that river. So they will rotate. So that type of, they will rotate and they will be connected to the generator and they will produce the power. So such type of arrangement is called as in-stream type of power generation. So here you can see single stage or cascade. Here again, here this is the single stage. So almost all the dams which we are so because that type of arrangement is not possible everywhere. So geographically favorable conditions are not possible everywhere. So this is a single stage dam. So once you release the water, so it will go forever. And afterwards also you can not, after releasing, you cannot use that water for power generation, or you cannot store that water after releasing in this dam. So that is single stage. So this is the quite opposite type. This is quite opposite type of thing, because you can see, so it is a cascaded type. So this type of sites, geographical favorable conditions should be available, then only this type of cascaded dams we can construct. Otherwise we would have constructed these dams everywhere. So because once you release the water and you can use lower after releasing at some time of this, ahead of this dam, again you release there, and after you can construct another dam and you can use this some ahead of the dam, some place ahead to the dam. So that will be very good actually. So how many times you can use this water, and that many times of you can again produce the power. So this is not practically possible actually in all the places. So that geographically favorable conditions should be there, then only these are possible. So, so majority are single stage dams. So that is a single purpose. So whether you are using the dam only for producing the hydroelectricity, that is a single purpose dam. So if you are using the dam for irrigation, for flood control, for fisheries, for tourism, along with the hydropower, So that is called as the multi-purpose dam. And next thing is the runoff river. So you can observe. So here we have not leveled up the water than its normal height. So we have just constructed dam, and the water which is flowing will flow, but in between the dam will be there. So it has not stopped that water to raise the level. So this type of rivers, we are calling it as the runoff type rivers. We are these hydropower plants that utilize the stream flow as it comes without any storage being. So why we need to storage? So we want to level up to increase the head. So here we are not using so. We are not doing so. On storage reservoir, so you can observe a clear difference for this dam. So the water, as it is flowing and moving out, that's all. It is coming to the dam and it is moving without any obstruction. Here you can observe. So water has came here and it has stored and it has not moved anywhere. So after so many capacity, after increasing the capacity, storage capacity of the dam, to protect the dam from being burst or damage or leakage, we will release only a small amount of water to protect that dam. So that is the other type of reservoir type of dam or storage dam. So that is the difference between the runoff and storage. So here this diagram clearly shows. So there is no water coming. Here the water is coming out as normally. As it is looking that there is no dam in between. Like that is coming. Here we have stopped it. Just like a mountain. And also here you can observe. See how these mountains are supporting for the dam, for the construction of the dam. So this type of favorable condition should be available, always available. This type of favorable condition should be always available. So for constructing a dam, which gives a long life for the dam and which decreases the construction cost of the dam, and also we can increase very good, we can construct to a very good high head. So that's why the construction of a hydropower plant is not like other plants. So we have to go to the place, we have to search the place which is favorable. If the river is there, so the river Godavari is there, river Krishna is there, So we were unable to construct. We cannot construct wherever you want to construct. So you have to study the path of that river, starting from where it is starting, where it is ending, and where there is more water, and where the geographical situation, where the hills or valleys are helping us to construct a dam, a big dam. So that we have to study, and after that you have to start the construction of the dam, which leads to the good life. So if you are constructing a dam, it has to. So if you take a thermal power, so its lifespan may be less. If you take a wind solar panels, you have to replace. Similarly, the windmills you have to replace. If you construct a dam, it will last for minimum of 50 years, normally 100 years, maybe more than that also. So the lifespan is very high for a hydropower plant because we are taking all the precautions. We are taking the support of the mountains. We are taking the support of the nature, and we are constructing that. And pumped storage, normally we use this type. We construct the dams which are constructed. This type of dams, we will use this type to meet the peak loads rapidly. So what happens here? We will be having a upper reservoir and lower reservoir. So the geographical conditions has to be favorable for this. Has to be favorable for this type of. So this is very, very rare. This and cascade types are very, very rare. So during the peak time, what you will do? You will just release the water, and you just release the water, and you will meet that load. And during the less peak times, you will just pump back the water which is stored, the released water which is being stored in the lower reservoir, and you will pump it back and you will store it in the upper reservoir, and you will be again ready to meet the peak load rapidly. So underground hydropower plants. So after listening this, you might have you might have not heard about it now until now. So these are type of dams are also there, especially for protection from the enemies, any bombing or all these things, and also for low head dams to increase the head. You can go for naturally it is having less low head. So if you go to the underground, so head naturally increases up to the ground level, head up to the ground level, and after the ground level. So you will get a very good head. So that this is underground dam, and these are the advantages already we have. So if you observe, if you compare, if you contrast the difference between steam power and hydropower. So initial cost is high for a hydropower. Running cost is high for a steam power, and cost of fuel is nil for a hydropower plant, and maintenance cost is quite low for a hydropower plant, and transmission distribution cost is more for the hydropower plant and less for the steam power plant because they are constructed near the cities. And fixed cost per annum is 13%, and this fixed cost is 10% for the. If you compare this hydropower with the wind power and solar power, so hydropower is the lowest cost for watt hour. So hydropower is always the cleanest and cheapest source of power. Whatever you can talk, it is always the cleanest and cheapest source of power till now. But wind power is low cost per watt in a good location, and solar power can be used anywhere. Usually predictable. Yes, hydropower is predictable and often does not require a large battery. So battery backup, that's not case for thermal power or hydropower. Okay. And the system is quiet and often can be made unobstructive. Typically low maintenance is very low. So it is very simple. Hydropower is very simple. And wind power is not high cost uh, than the hydropower. And a smaller system can be low maintenance. If you are using a smaller, normally we will go for a larger wind turbines because the cost per unit will decrease. So, but if you are going for a smaller systems, the maintenance will be less. Okay, so because the smaller systems, there is no mechanism of changing the angle, changing the directions, all these things. In that case, it will be the maintenance will be less. It is also predictable. If you come to the solar power, that is, it is everywhere. Extremely low maintenance. So maintenance is low for the solar power, and lifespan is large and can be operated and unmonitored for extended periods of time. Okay, that is maintenance. You can extend the time. And predictable power, it is also a predictable power. Installation is very, very simple. So installation cost for hydropower is very, very high. Installation and also difficult. It is also silent and abruptive. If you come to the disadvantages, so not suitable everywhere. So we have to construct where the location is favorable. Similarly, if you modification, you have to modify according to the water resource. And initial, so that means if the water is excess, we have to release all this. Initial installation cost is high, and in colder climates, what will happen? The water will become ice and it will not flow, and we have to stop the production of the power naturally. Moving parts. So here they are having moving parts. So only where you cannot find moving parts is that is solar photovoltaic power. So wind power. So you cannot place everywhere. Only the where wind potential is good, and towering is very, very expensive. So the people will generally reject. So it will give so much of noise. Okay, and this is here also we will be having a moving parts. So the moving parts we have to replace wear and tear. And solar power, high initial cost and power output can be variable in different areas because of this longitude and latitude process and seasons. So here is it needs a good solar exposure. So you need a sunshine recorders to find what in the day how many hours are the sunshine hours. So if clouds are coming, all these things. So the expected power it will not going to develop. So thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.